Hi, this is Christoph, and I'm going to show you in this little demo how you can use data types in Camel 4 to actually perform transformations as part of your camel routes. And later on, we will also be using data types in Kamelets and Kamelet pipes, which give you a huge improvement in terms of interoperability in Kamelets. So let's start with this little demo route. This is a quite simple route, timer to log, and it uses a constant body of type camel rocks. And let's start this little application, and then we see that this route is periodically logging this data to the output. So with Camel, you can use the transform enterprise integration pattern, and since Camel 4 you can give a so-called data type in here, which usually gets a name, and each data type also comes with a transformer that also gets the name. And the transformer is able to use different implementations and different things to do the transformation. One of them is to use the data types and data formats. So we can use the base 64 data format implementation in Camel and declare this as a transformer with this name and then apply the data type to the route. So let's wait for this to restart, and then we can see that this base 64 data format is applied, and we have this body type which changed from string to import stream. So we can also use custom data type implementations. So let's use some uppercase implementation, and this time we are not using the data format, but we give the Java class implementation of this transformer. And when I apply this, we have this uppercase data type now on the route. And let's jump into the implementation. It extends the transformer SPI in Camel and implements this transform method and gets access to the actual message that is being processed on the route. And it gets access to the data type from and data type to. So if you really want to make a very specific transformation from one data type into another, you can leverage this information in here. This implementation is quite simple. It just uses the to uppercase representation of the body string. So instead of using this name and the Java class, we can also do a class path scan. So in here we can say camel demo transformer, and this is the package where the actual transformer implementation is located. And if this restarts, it should again use this uppercase transformer, because this is one of the available transformers in this package. So when the route is starting up, Camel will do this class path scan in this package and search for available transformer implementations. And this is using the data type transformer annotation, where you can specify the name of the transformer, and you can also specify the from type and the to type if you really want to declare that the transformer is only capable of transforming this very specific from type and to type. So this is now doing using the class path scan. And last not least, we can make use of the service locator pattern, where you add a file using the class of the transformer, and now Camel can do a lazy loading of the transformer when non-specific transformers implementations are giving in here. So if this restarts, it still should work, because we have this service locator already present on the class path. So instead of using the custom implementation, we can also use out-of-the-box implementations. So one of them is the application minus cloud events. And this is a data type that is provided by Camel 4 out of the box, and it will apply the cloud events specification. So you can see this in the output. Now we are back to using camel rocks and string as a body, but in the header information we can see some cloud event specific headers like the CE ID, the CE source, spec version, and so on. So this is coming from the cloud event specification, and now we have some proper values set because of this data type. We can also use the JSON binding, change this to application cloud events JSON. And then when this restarts, we see that the content type is now cloud events JSON, and we are having a JSON structure as a body where the camel rocks message is giving in this data field, and we have things like spec version, ID, source, type, which are all coming from the cloud events specification. So this is how you can use data types. Let's maybe have a look into the out-of-the-box transformer that is located in the Camel Cloud Events jar file. And this tries to set proper values according to the cloud event specification, reading data from the message and the exchange, and setting the values in the header sections. And also this is the cloud events JSON binding that also tries to set meaningful values according to the cloud events specification. So right now I was using the transform step in here and give the data type. Instead of this, you can also declare a so-called input type. Let me just use this. So this route in here, it declares an input type of application cloud events JSON, so that every call to this route will actually use this specific input type. If I now change this to CE minus JSON, then this route is calling the direct endpoint on this route, and now the input type of application cloud events JSON is automatically applied to all the calls on this route, and after the reload it still uses the application cloud events JSON data type because this is the input type of the route. And now we have the opportunity to actually declare some contracts between routes where we can use output types and input types and do automatic data transformations based on this data type informations. So this is how you can use this in pure Camel in your routes. Now let's stop this and move on to use this also in Kamelets and Kamelet pipes, which give you a huge improvement in terms of interoperability. So let's see how this works. In this part of the demo, we will be using data types in Kamelets and pipes. And let's have a look into a sample Kamelet. This is the AWS S3 source. And besides doing the specification for properties, the Kamelet can also expose the data types. So in this data type section, I'm able to actually expose all the data types that this Kamelet is able to produce as a source. And in this out section, we have a default data type, which is the binary data type. It resides to this data type in here. And this is the default one when using the AWS S3 source, presenting the content as a octet stream, meaning a binary stream. On top of that, the Kamelet is also able to produce cloud events output, and this uses then a different data type, which is specific for the AWS S3 component, and it is also following the cloud events specification, setting proper values for all these cloud events data like the source, the ID, the type, and so on, but this time it uses the S3 information to actually provide some proper values. For example, the cloud event type will be the AWS S3 get object, saying that we actually did this operation on the AWS S3 bucket. So in a pipe, we can use the source as usual in the source section of the pipe. We can reference the AWS S3 source and we give some properties like the bucket name and so on, and some connection data. And we can also specify the data type that we want to apply as an output of the Camelet. So the Camelet defines these different data types, and one of them is the application cloud events that I'm using in here in this pipe. And then I'm just logging things, and in the sink where I'm connecting to an HTTP endpoint, I can again use data types on the HTTP sync Camelet in order to say, now I want to transform the application cloud events data into an HTTP binding. And then I can combine these data types from AWS S3 with the HTTP. Both are using the cloud events specification, and then I'm provided with the proper HTTP binding for the cloud events. I can start this little pipe locally using the YAX testing framework. So this should now create a test container for AWS S3, and it will invoke a file on that bucket and make sure that the HTTP endpoint is receiving this cloud events data. So let me just scroll in here a bit and see here the exchange in the logging. So right now we can see a lot of AWS S3 related headers, and then on top of that we also see some cloud event related headers that are set because I was using this AWS application cloud events data type. And this information is able to be used in the second data type here for transforming this into a proper HTTP binding. So this is how it works, and this combination gives us a lot of improvement when connecting multiple Camelets, where I was reading from AWS S3 using the source and connecting this to an HTTP sync using the HTTP binding of the application cloud events. And I can also show you like the AWS S3 cloud events data type transformer. This is coming from the AWS 2 S3 component in Camel, so it's a out of the box provided transformer that I'm able to use everywhere to actually set some proper application cloud events headers from the AWS S3 source. So this makes sure that we are using proper cloud events headers. Another example that I want to show is like a Slack to Kafka pipe. In this pipe we read from a Slack channel, and this time I want to actually extract some text from the JSON structure. So the Slack source will give me some JSON structure as an input stream. But with the data type, I'm able to actually say, I want this to be in the format of application -x struct. And this will automatically transform this into a JSON node using the Jackson library. So I can also open this JSON struct data type, which is the application -x struct. And this is able to transform this into a proper JSON node and uses the Jackson library for that. And once I have this in this generic JSON node structure, I can make use of that in the extract field Camelet, for instance. So this extract field action Camelet is able to operate on such a JSON node extracting a field named text, which is the user input in the Slack channel, and then I'm able to actually work with this. So it's quite easy to take this Slack data, transform it into an application extract, and then make use of that in the extract field action. And in the sync, I'm binding this to a Kafka topic, and now I'm also transforming this back into a plain text, because before this was using this JSON node structure, and then I'm just formatting this into a plain text and sending this to Kafka. Let me also show you this running. Let's clear the buffer here, and let's run this Slack to Kafka pipe. And this will also then start some test containers and invoke the Slack integration, reading some data from the Slack channel. And then this is successful, which is good. And then let me scroll up a bit. And here we can see this is the actual Slack message. And now that I was using the application extract format, I'm using this also here in the content type. And here you can see this is now using the Jackson object node and uses this JSON structure here. And the extract field action is able to use this text field then and extract the pure message that the user has inputted into the Slack channel. And this is then here what is the outcome. Now we have this camel rocks as a body. So this example should show you that with the data types in Kamelets and pipes, we are actually able to increase the interoperability between Kamelets, because we can transform into various data types to actually work with the data from the source and putting it then to the sink. And this gives us a huge improvement because everything is more declarative in here. I just give the data types that I want to have, and then the transformation is done automatically behind the scenes. So thanks for watching, and have a nice day.